As most of us know, chemistry is the study of matter, and in this screencast I'm going to talk about chemistry in space. But to be more specific, I'm going to talk about spacecraft propellants and propulsion. So basically, what is a propellant? A propellant is a material that moves something, but in the case of a spacecraft, it's a material that gives it thrust. This can be linked to Isaac Newton's third law of motion, but every reaction has an equal and opposite reaction, as the mass expelled out of the rocket creates a thrust in the opposite direction. This can be seen here by these two arrows equaling the same length. In a space rocket, a propellant, which is a fuel, is burned, and this expels hot gas out of the bottom of the rocket. This creates thrust and moves the rocket upwards, as you can see by this diagram here. There are two types of propellant: liquid fuel, which is usually liquid hydrogen and liquid oxygen, and solid fuels. Okay, so let's now look at current fuels in space rockets. The main liquid gas used by rockets is liquid hydrogen. Liquid hydrogen is extremely light and has the lowest known molecular weight of any substance, so this helps with the weight of the rocket, making it more light. Liquid hydrogen also burns at a high temperature of 5,500 Fahrenheit or 3,310 Kelvin. Normally, liquid hydrogen is combined with an oxidizer, which is usually liquid oxygen. This helps oxidize the fuel as in space there is no oxygen readily available, so the oxygen must be carried up with it in the form of the oxidizer. Liquid hydrogen and liquid oxygen are both cryogenic, which basically means they are stored and created at low temperatures, as liquid hydrogen must be at minus 423 Fahrenheit or 15 Kelvin, and liquid oxygen must be at minus 297 Fahrenheit or 90 Kelvin. As previously mentioned, there is also another type of fuel, which is solid fuel. Solid fuel boosters, which are made up of solid fuel, are used in coordination with the liquid fuel. This helps give the spacecraft an extra bit of oomph when taking off from the launch pad. A solid fuel booster is broken down into various components. 16% of it is atomized aluminium, which is the fuel, which is quite surprising really. 69.8% of it is ammonium perchlorate, which is the oxidizer, and 0.2% of it is iron oxide, which is the catalyst. 12% of it is polybutadiene, acrylic acid, acrylonite, which is the binder, and 2% of it is epoxy curing agent. Okay, so now let's look at new propellants and proposed propellants. Even though current fuels are extremely efficient and powerful, space is just too vast, and it still takes many years to explore various places such as Saturn, Jupiter, and other planets, so new propellants are needed and desired. New propulsion methods that have been proposed are ion propulsion thrusters. But firstly, we need to know what an ion is. An ion is simply an atom or molecule that is negatively or positively charged. An atom becomes negatively charged if it gains an electron, and becomes positive charged if it loses an electron. In an ion thruster, the propellant atom needs to be ionized. So to do this, it is electron bombarded, which involves a high energy electron, which is usually with a negative charge, colliding with the propellant atom, which is usually xenon. This releases a second electron, yielding two negative electrons and a positive ion, so overall the net gain is 1 electron. Another method of creating ions is called electron cyclotron resonance, ECR to be short. This involves using high frequency radiation coupled with a strong magnetic field to heat the electrons, causing them to break free from the propellant atoms. This creates plasma, so the electrons can then be taken from the plasma and used within the ion thruster. Most ion thrusters use xenon as a propellant gas, which is chemically inert and colourless. So how does an ion thruster work? Ions are accelerated by electrostatic forces, positive and negative forces, so oppositely charged ions attract each other. This is created by electrodes positioned downstream at the end of the thruster. Since the ions are generated in an area of positive energy, they are attracted to the negative electrode, which creates thousands of little ion jets propelling down the thruster. This creates ion jets, which can then combine together to form an ion beam. Sounds pretty cool. Modern ion thrusters are propelling spacecraft up to 200,000 miles per hour, whereas a normal space shuttle has a top speed of around 18,000 miles per hour. However, with these ion thrusters there is only a small amount of thrust, so it's not good for propelling heavy loads, so they're used mostly for satellites, basically propelling them around there. Whereas modern thrusters are still used to take like heavy loads up into space. This ends the screencast of spacecraft propulsion.